looks as if it has pop. Did a cell pop, or is there something on? Well, that's a little concerning, guys. It definitely looks like large buildup of heat right here at one point. Oh, guys. Oh, guys. Oh, look what I got. Look what I got. Look what I got. Oh, God. Oh, God. Oh, God. Oh, she's a big boy. I know I'm supposed to be taking apart the river battery, but I got this in the mail a day early and I really, really, really want to take it apart. So we're going to do that this week instead. And then hopefully by next week, I'll have my ducks in a row and we can actually dissect that river battery. But yeah, I got 2 of these guys. I put a post up a few weeks back. Some late night shopping on eBay again. Got 2 of these guys. I paid $1.99 shipped each for them. And I understand why they wanted so much, because these things weigh a ton. They're a little over 50 pounds a piece. So far, one of them, when I push the power button, the screen turns on. This one does not. Now, I've already done a little bit of digging because it's kind of hard to show these up here. So I did it over there. But the unit where the screen turned on has apparently a faulty AC port on it. Anytime I try and plug an AC into it, I get an AC overload message on the front screen and it dies. It goes into a fail mode, and because the battery was at 0%, it dies. Plugging it into DC though, it immediately took a charge. This one I wasn't quite so lucky. This one I plugged it into DC and immediately got the red battery of doom, which essentially tells me that either this has the same issue that the Rivers had, where there's an issue, it's just not going to try and recover the cells once they go below a certain amount, or it could be some kind of an imbalance. There could actually be an issue with the battery pack in here. Now, in my post, I said that we were getting into LiPo cells. I was wrong. I thought that those River Pros were the only units that were ever sold by EcoFlow with the NMC cells in them. And unfortunately they weren't. So this is a Delta Max 1600. Comes in 3 different flavors. We've got a 1600, a 2000, and then I want to say a 3000 as well. I could be wrong on that. Don't quote me. I don't even think they sell these units anymore. Everything EcoFlow has done has gone to LFP batteries. So this is one of the last of the NMC style batteries. This one is a big one though. This has a little over 1600 watt hours in it. So it's a little over double what the Rivers have. And it also puts out up to 3000 watts at its boost capacity. So because of that, this one, without any kind of a helper or anything, will be able to power your fridge, air conditioning, small air conditioning units. And then charge a lot of extra things off to the side as well. So kind of excited to get into this. I'll show you guys around the unit real quick as much as I can, because it is a bit of a chunker. Oh, hopefully this new desk holds up well. So up top here, we've got the QR code that just tells you to go and download the app. Nothing special there. You guys can scan it if you want to, or you can just go into your app store and look up EcoFlow. It's the same thing. Just like what we saw in the Rivers, we have a charging flap here, and they can be kind of a pain to get off. There we go. But this one has a couple different options. So it does have your DC input. This one takes up to 100 volt DC though. So this is really meant to be a solar station, a solar generator. This can have a bunch of panels in series and be able to take all of that extra voltage at a lower amperage. 100 volts at 110 amp max rather means that this can take up to 1000 watts at a time. So pretty awesome there. On the AC side, it's actually even faster. It can go up to 3000 watts AC charging. I don't know how you're going to do that on this style plug, at least not here in the US, but maybe over where there's 240 volt you could. But yeah, it says in the app up to 3000. I think you could probably get around 1500 to 2000 in the States. Now down below on this one, you do have quite a few extra ports compared to the River Pros. So we now have 6 instead of 3 AC ports. We also have our CLA or cigarette lighter adapter, which is your standard port for your like car accessories. And then we've got a couple of barrel jacks here that can output some power as well. Oh, now flipping it over to the front. Oh, we're about to test this desk out and see how well it holds up. Ooh, if anybody needs a desk, look down in the description. I'll have a link to this one because so far it's doing pretty well. Up front here, we've got the screen just like what we had on the Rivers as well. It actually has a very similar readout to the River Pros. And then we've got four USB Type A chargers, two USB Type C chargers. These can both go up to 100 watts, which is pretty nifty. I haven't tested to see if they take input. I doubt it because they don't say it, but maybe we'll plug it in here in a second just for poops and giggles. It does have Wi-Fi built in just like the Rivers, and it connects to an app just like the Rivers do. On the side here, it has two expansion ports for extra batteries. So a little bit more common than what we saw on the Rivers, and this, it seems, is what EcoFlow's going with, except for their really, really big units that use something that looks like an NACS or a kind of like a Tesla charging plug, but it's not. And then on the other side, there's nothing except for some vents for the fans that blow air through the unit over, assumedly, the AC components. So this guy, again, I can plug it in. It ramps up to about 300 watts charging, and then it just shows me that red battery icon. I was able to go ahead and plug it into DC, and it will run long enough that I was able to get it on the Wi-Fi, hook it up to the app, and I did find that it had the version 1.0 software. So again, I'm wondering if it's a similar situation to the other unit. What I want to do with this one instead, though, I do want to go ahead and take it apart. I want to really reuse the AC system out of here and the battery out of the other unit to make one good solid unit. And then from there, I can kind of toy around with the other unit, see how it's working, and see if I'm able to go ahead and do anything with that one at all. Maybe it is just a little low. Maybe it's below 2.2 volts, and that's where the BMS is saying, nope, don't give me any juice. Hopefully we can find out here shortly, actually. So for these guys, the reason why I've got you all up top right now is because we actually do get in through this top panel. At least I think. I can't find any other way without taking the feet off to get into this unit. But I did notice when I was picking around earlier that this guy pulls right off and reveals a bunch of Phillips screws. Ooh, where'd my screwdriver go? There we are. Knew I had it in here somewhere. All right. So we're going to go ahead and take off these 12 Phillips screws, it looks like. And hopefully that'll get us into some guts here. Already I'm not loving what I'm seeing. It looks like half of these screws are already unscrewed. So that's not great. Yeah, these are all loose. I felt like when I was picking this thing up and moving it, there's a tight one finally. I did feel like something was jangling around on the inside, so I got a feeling whoever had this unit, they may have been handy and tried to open it up themselves to see what was going on in there. Focus. Man, the second one that's tight. Oh, and we've got 3 tight screws. I don't got a lot of confidence in this now. Oh, hey, looky there. Isn't that nifty looking? So up top, not a whole lot we can actually make off of this this main board here. I don't really know what this board is per se. We need to get it open up a little bit more so I can find out, but I see a lot of resistors and capacitors on it. Yeah, I have no idea what that could be. Maybe it's the charging board? That would perhaps make sense. And it does look like this one's a little chunkier than what we were working with the Rivers. So we do see some metal components in here that appear to go, at least as far as I can see, all the way down to the bottom. So that's good news. We've got some reinforcement there, and it's not just screwing things into plastic. We do have these plastic side panels that it looks like we can take off just with a couple of screws here. All right, so I'm gonna go ahead and start unplugging stuff here. So that's our battery. And you know what? There's no way that that's not behind a BMS. This couldn't be the BMS. It's no. So there's no way that there's any voltage coming out of there, but you know I gotta test it. So the entire top of this board is somehow like conformal coated. So it definitely has some water resistance built into it up top here. And my meter here is plastic, so I ain't scared. We're gonna go ahead and put this on DC voltage like we do. And then we are going to test. Flat side on the XT60 is positive. Other side is negative. Yeah, that's what I thought. We got nothing coming out of there. 103 millivolts, that's nothing. Okay, so that means we get to unplug the charge side circuit here. XT60I-F. That's an intelligent XT60 connector. Got an XT30 under there. I'm gonna go ahead and take these screws out first. So far my camera's telling me everything here's in focus. I hope that's right, except for this stuff. This stuff shouldn't be in focus though, because we're up top here. This is a pretty large unit. I am really hoping I can get this working, because if I can, there goes the fridge problem completely. So the river units, those were going to be great, but they can't take in as much power as they can put out. A fridge doesn't use that constant power like that, so it shouldn't really be that much of an issue, but I just didn't think that during the day, with the amount of solar that I could put into them, that it was actually going to be sustainable. I was still going to be using cars to charge them up and stuff like that. This guy can take 1,000 watts in on solar. That is way more than enough during the daylight hours in Florida to be able to cover for what a fridge is going to use. All right, so lifting this up just ever so slightly to see what it's hanging on currently. So we've got this XT30 on this side, and it doesn't appear to really be hanging on that too much, but there is, oh, there we go. We've got these other sense wires or whatever this is. Maybe it's a fan wire? I honestly am not 100% sure there. We're going to get it pulled right out from its connector. Come on, buddy. You can do it. You know, we don't have to show this part on camera. Me using the wrong tool. You guys are gonna see it disappear though, damn it. I'm so not good at this. All right, I got that guy out there. We got an XT30 under there. And I don't know that this guy comes off. So we're just gonna unplug the XT30. Okay, so now I can flip this over. I don't believe this is one of those weird connectors that looks like it's plugged in, but I don't think it actually is. Yeah, I believe that this is one of those like direct soldered, and so that means that I've got to unplug it from the screen side here. Only slightly sketchy, just like everything we do. And it doesn't want to come out by itself, because of course it doesn't. So let's give it a little bit of motivation. There we go. So these are glued in, I think, from the bottom. No, maybe not. Maybe I'm just weak. Okay. All right, so now we can flip this guy over here and see what we're working with. I don't want to set it down on those metal posts just in case any of this is still electrified. And it does show I'm in focus, so hopefully my focus peaking is actually working here. So this is that DC charge circuit. This is what allows us to take the DC in. It appears, based on what I can see here, to be a UV or solar MPPT charge circuit. MPPT stands for maximum power point tracking. What that does is it allows, no matter what your solar panel's voltage is coming in at, even if like the clouds cover and it's maybe not getting that full voltage, it allows this circuit to then still convert it into a usable voltage for your unit. So if you get some cloud cover and things like that, back in the day before this, before we just had these smart inverters and everything was kind of dumb, you would run into situations where the clouds would go over, the voltage would drop below what your base unit could accept in, and so you would just stop charging. Now with these, even if they're only getting 3 or 4 volts on this side, they still have the circuitry to go ahead and boost that up to a usable voltage as long as the amperage is still there. So it gives you much more consistent much more consistent power delivery throughout the day, and allows you to plug in a very wide range of inputs into this type of device. So this by itself is actually a pretty nifty board. We're going to go ahead and put it off to the side for now. There are some test points on here as well for, it looks like 24 volt output. So I'm guessing that's what it's actually charging the battery at. And we're going to take a look in a minute and see what that battery looks like and how large it actually is. All right, so it looks like the next thing on our agenda to get taken care of here is going to be this A-B plate. So it appears to me that there's a few screws. Let's see. So the fans are connected to this plate. So when we take this up, we'll have to unplug the fans as well. No big deal there. We've got 4 fans, 2 on each side. These guys are blowing air through and those are sucking air out. So it's just a straight through configuration, and it goes through all of these different heat sinks for the AC current, for the AC circuit here. So we're going to go ahead and get started on getting these guys out here. So we've got a total of 8 Phillips, again, screws. They're nice. They didn't make us switch it up or switch over to some weird funky screw type. All of these screws so far have been slightly different sizes. Luckily, I've got everything recorded so I can go back and find out where they all went. But you guys really should, like I said in my first camera teardown video, have some kind of a tray to organize these parts. With how big this guy was, my tray wasn't going to fit up here, and so I decided to forego it, and I'll take the long route getting this put back together. Now, I like to generally go into these things a little blind. I may, after a few minutes here, if I don't get very far in the AC side, pull up a quick video on the teardown on these, because I really do feel like this side panel should come off and give me straight access to the battery. And if I find out that battery's only a couple of volts below nominal, I'm charging that sucker. I like 18650s, and 18650s like me. All right, we also have one last grounding screw here, and it looks like this XT30 is actually connected on there. I wonder if I can take... No, I can't get those grounds off because those are actually soldered into the ground plane for the AC outlets here. I wonder if this guy will actually work with my kilowatt meter, because I tried doing that for our drain test on the rivers, but the rivers don't have an actual ground inside of them. There's no even combined ground, so it would not turn on the kilowatt meter, but I wonder if this one would. All right, so now we have all of our fans need to be unplugged. Luckily, these are just standard 12 volt fans. Looks like they are voltage regulated, not PWM. So they do have the ability to ramp up and down their speed, but they don't have as precise of computer control over them. Can't turn them off. All right, so taking a look at this mid frame here. Again, hopefully will be in focus for y'all. I can go ahead and refocus on the fans here if you really want to see them. There's really nothing much to them here. If you want to see what the brand of fan is, there's your brand and model, 12 volt, quarter amp, beefy little guy. All right, so now that we've got that taken out, let's see what we're working with here. So let's get you all back in focus. Hey, looky there, we can see stuff. All right, so we've got our main board model number here. This is an MR310 PSDR V1.0.5, made in 2021. Again, these things are so new. It stinks to see them just like get thrown away. Again, I think that I want to say from memory that these, well, you know what, let's not get into that yet. I want to do some more testing on it first before I really get into what I think is going on underneath it. So we do have a couple of things going on here. We have a honky boy. What does this go to? So this is an XT90 connector. We haven't run across one of these yet because it's not been something that's really been necessary in anything that we've used. But an XT90 connector right there can take up to 90 amps of power. And yeah, that's a chunky one. That goes all the way down to the, why would they don't need that on this. Okay, we got to figure out what that is. I don't know what that goes to. Maybe this is one of the connectors for the external batteries. That's the only thing at this point that kind of makes sense to me there. So let's go ahead and keep digging in here. These metal plates do appear to go all the way down and through, and I don't think that they're going to end up coming off for us. I do want to stick my head in here, and sorry, I'm going to get in your way, guys, but I want to see, I'm not just a complete idiot, am I? I might be. We'll find out. Let's see. Oh. All right. I think we take the AC charge circuit out and we get down to that battery. So these guys here, they are open connectors, but because the BMS is there and it's already cut off the voltage, I don't really have to worry too much about crossing these. They're going to be the last thing that I take off here though. We do have a bunch of screws around the board though that I need to go ahead and get out. And then that should allow us to pull this AC board up and out of the unit, giving us finally some access to the batteries. And hopefully I can find out how to get this open a little bit more easily for the next one. All right. Okay, yep, that was it. All right, so the last thing that we have is going to be the two main connectors here for the battery. All right, just going to cover that guy for now with a little bit of heat shrink. just to make sure that it doesn't cause any kind of a fail mode or anything in the BMS if those two cross. Usually the BMS is made to go ahead and avoid short circuits so that if they do cross, it will cut the voltage off. Voltage is already off in this case, so I again don't think that there's really any danger here, but I don't want to fry this board if I don't have to. And making a silly mistake that would fry it would feel, well, kind of silly. All right, so we do have another connector that we can take off here. I believe that's the last one, except, oh, I missed this giant guy right here. Another XT90 for the other set of assumedly AC ports. Okay, so that is just all the AC charging going through those XT90s. That's some big expectations, I guess, out of those guys. All right, we're still hung on something. Oh, okay, there's a connector over here for the screen. We knew that. We had it on the other side as well. There we go. All right, so I'm going to go ahead and lift this off using the heat sinks just because I know that those are usually pretty well held on there and they are not connected in any way to the electricity. Oh, okay. You got to come off there, do you? There we go. All right, bottom side of this board is not going to be very interesting, I don't expect, but I've been wrong before. There is a little bit of circuitry down here. Not sure what any of that is. It's all going to be for the AC side, and you do see that giant danger. Again, this is not something you're going to try at home. We're getting somewhere now, guys. Okay, so they did switch it up on us a little bit. We got some different screw types here now. And I'm afraid I might have been wrong. I don't think that these metal plates do go all the way down. That stinks. All right, but do the front plates come off like the Rivers? No, that'd be too easy. Does this guy want to come off any better now? All right, we'll keep going the right way, I guess, and taking screws out the boring way. So we got a 20 amp fuse on our AC input. That makes sense for the States. All right, so if we continue on here, we have 8 additional screws that we need to take out. 4 of them are going to be Phillips head, and then 4 of them appear to be a hex head screw. So I'll need to grab my other set here. And these are stainless, so they do not want to stick to the screwdriver. So I've really taken most of the dangerous stuff out of this unit at this point. The battery itself is not putting out any voltage because of that BMS being tripped. So at this point, there's not too much in here for me to be really afraid of. I do need to get a different screwdriver out, and it's easier to move this than it is to move that at this point. Hey, there we go. No shot. This is actually the right screw head. You guys are going to think it's scripted if it is. Ah, darn, too big. So if we're playing along at home, this is a hex 4. So working with this guy here, luckily, it gets bigger. So we can get right down in here. This one's not insulated, so somebody can yell at me about it. But guess what? I already said that there's really no danger in here anymore. So bite me. Well, I've got good news and I've got bad news. Good news is that all those were tight. So that leads me to believe that nobody's gotten this far into this unit yet, which is, in my opinion, good news. The bad news is that with all those screws out, she ain't budging. What do we have to do next? Let's see, maybe just removing these will allow those front plates to come off. Oh no! Put it back on, put it back on! There's supposed to be an earth-shattering kaboom! All right, got that off. Doesn't seem that anything else is like popping in or out or along with itself. This has to come up. It does. I'm such an idiot, guys. You just have to pull on it. Well, that would have made things a lot easier. All right, still can't really see much in here. Right now I'm just looking at a plastic panel, but it does show me the screws that I need to get the front plates off. Let's see if the other side does the same. I bet you $1 it does. At least now I don't have to be as sketched out about taking this apart. Silver linings. It only made sense to me that they would pop up, but I tried to pop it up and it didn't want to pop up. Well, maybe you should have used your muscles. Yeah, well, maybe I should have read the manual. Are you gonna do the same? Oh, looky there, that one came off actually easy, so that's fun. So yeah, this is what I was thinking on these EcoFlow boards. So I'm gonna show you guys what I'm seeing here. So the good news is that water detection indicators have not been tripped. So this guy hasn't been in the water at least. which I kind of expected. I didn't see any signs of water ingress whatsoever. So these are the main battery connectors. We've got, or rather, connectors from the BMS. So we have here your main positive, and we've got here your main negative, and then there's these full metal bus bars that go between some of the different cell groups. So I believe that we're going to be able to get some voltages off of this side. So let's see if we can. So I should get nothing from the main positive to the main negative. We kind of expect that because that's what's coming through the BMS. The rest of this looks like it might be as well. We might have to actually tear down further to be able to get what we're looking for here. But let's go ahead and leave our probe on our negative here and go to some of these other points and see if we've got anything coming out. Nope, I got nothing here. Yeah, these are all showing up as millivolts, so that is nothing at all coming out on these. These could just be the, oh, interesting, there's some buttons. What? I like buttons a lot. These could just be the bus bars for these external battery connectors, which by looking at how they're configured, I think that's actually what I'm looking at here. But there's buttons, guys. I like buttons. I want to push them. Okay, we're pushing the button. There's two buttons. Button one. Oh, button one made it flashy. The BMS appears to be coming on. I've got a white light in here now. Oh wait, these you have to press and hold. Okay, my white light disappeared. There's another button. What does that button do? That button didn't give me a white light. I like this button more. Yep, that button gives me another white light again. And that turns it off. Interessante. Still nothing coming out of the battery, so okay. So yeah, we're still getting nothing out of there. A white light on the BMS though tells me that these have enough voltage that the BMS is at least able to turn on. I see one other thing in here I want to probe. So I've got access to, I'll pull you guys over again for this. So I've got access, if we look down in there, to B7 it looks like. So that's going to be assumedly battery cell 7. And I believe that's a B8. So I'm wondering if I can probe between those and see what kind of voltage we have on here. Oh, this might work, guys. This might work. This might be working. All right, let's take a look. You still in focus there? You can still see me. I don't know which way is positive, which way is negative, but it doesn't matter as we know. Oh, 3.6 volts. I like 3.6 volts. So I'm going to go ahead and first take these main terminals off. Oh, they are in there with some Loctite, assumedly. Makes sense for some, nope, no Loctite. Okay. They were just really in there. All right, so we've got our main positive out. No longer have to worry about this guy just flopping in the wind. That's beautiful to see. Let's get our main negative out. Ah, there we go. We are working with DC, so we can say positive and negative. This is not AC, where we would be talking about neutral and live. Now I'm going to put these screws back in just so I don't lose where they go, because it doesn't appear that they interfere with taking the rest of this unit apart. All right, so I do have some extra screws here that allow us to take these off, I'm assuming, once we get past this. But really, I just want to focus on this main board area here and see what I can get out. So let's first unplug our data line, move it off to the side. I'm not sure if I even need to mess with any of these bus bars at this point, because they may be holding this plastic in. There's some black screws up top here. Ooh. We don't have any exposed contacts on the battery except for the ones that are there, and I'm not going to be able to drop something that goes that way because that's not how gravity works. There we go. There we go. Okay, that is one interesting way to put that together. Yeah, I did snap a little bit of the plastic off from there. All right, so this guy, yeah, he's not going to come out until I take the front panel off anyway. Yeah, I guess that's what they want you to do. Well, damn. Okay, so this top panel's going to come off with just a couple more screws. That's good news. All right, let's go ahead and move this around once again. Missed one up here, it looks like. Didn't get it all the way unscrewed. Same over here. Nope, that one's unscrewed. All right, beautiful. We got the metal plate out now finally, so that guy can go off. So yeah, unfortunately that metal didn't go all the way down to the bottom like I thought, which I guess as long as there's metal on the bottom as well, we'll assumedly find out. Then, yeah, maybe we'll get to some more of it here in a second. Let me keep going down. I got two more screws here to get this top or front panel off rather. Seems like these things are really built around the battery. It's almost like they set the battery into this bottom tray, screw it in, put the side panels on, or the front and back panel rather, on, and just kind of keep going from there. All right, there's no more screws there, so it should just unclip, assumedly. And it did. Beautiful. This is going to be the front control board. Forgot which side we were working on all of a sudden. So this is going to be the screen and some of the charging components for your USB ports. And then we'll go on this other side panel, which is just a couple of screws on this side. And rather than lifting up what I'm assuming is still about 40 pounds worth of battery, I'm just going to go over to this side. It is actually a lot lighter now. Hey guys, how you doing? It is actually a lot lighter now without the AC charging components in there. All right, so now that we've got that off, we'll undo the clips. Oh, there we go. The back side of this board, again, we've got all of our AC inputs there, and then our DC main inputs there. So those two XT90s that we were looking at, one of them carries to the to the AC outputs, and then one of them carries it to the AC inputs. So that's what we were looking at on that. All right, so now we basically just have a battery left. We've got a battery, and yeah, there's a little bit of a bottom panel on here, but that's it. All right, so this is a big battery. This is a chunky boy faux show. And I believe what we have to do is crack it open by unscrewing. There are Phillips screws, which unfortunately you guys can't really see from your perspective. I've got my finger and my screwdriver finger on one of them on each side here, and they're holding these two halves of this plastic shell together. So I'm going to go ahead and pull see the battery itself. So right now we're still just looking at some kind of distribution board, be it for the external batteries or for something else, I don't know. Won't know until we get in here, I guess. All right, we've got some deep screws inside here as well. The other ones are straight through, so this goes straight through to the bottom, and that's how it kind of, that's where those longer black screws were going. And then we've just got your plain silver plastic-based screws on the sides and on the back here. Trying to do this blind is fun. There we go. And I assume once we get these out, we're just going to be able to pull the top of this panel off, which will expose the battery in full. At least it's gotten a little smaller since we started with this venture, so it can now fit in the screen a little bit better. Oh, and guys, I tell you, I'm excited to get out of here tonight. So, unless you're family or friends, you don't know that. Ooh, oh, that's good looking. All right, so I've got my battery negative right here, and lots of cells. Wow, this is something else. All right, so what we're looking at, 16 cell configuration per parallel group. So what I'm looking at here is I've got negative, positive, negative, positive, negative, positive, negative. And that is our battery configuration in here. So, wow, okay, cool. So let's find out where our weak cell is. I'm excited to figure this out. All right, so let's go ahead and, you guys are probably tired of hearing me say it, but turn it on to DC voltage. All right, so we know negative here, positive here. That's 3.63 volts. Negative here, positive here. Oh, don't worry about that. That's the same set. All right, I would actually have to get from the other side here. So let's go this one to this one in that case. 7.26 volts, which is approximately times the 2 that we were looking at there. That's good news, 7.62. So I have 21.8 volts here. What's wrong with this battery? All right, I think we need to be able to see the bottom of the cells as well. Wait a second. Oh, that comes out just like that. Looky there. We're going to turn the battery on this side. Okay, so yep, we've got cells all the way straight through here. With how tall these are, we've got to have two 18650 groupings going on here. So we have our battery positive and battery negative. It was just covered before. So we can see what we are currently getting out of this guy. Maybe. I got 43.61 volts coming out of here. That's a good amount. So this pack is fine. Is there just something wrong with the BMS, or is it truly just a matter of the older firmwares would not charge them if they dropped below 3.7 volts? Okay, so what I'm gonna need to do with this one, guys, or what I want to do with this one rather, the other pack was able to charge on DC voltage. Again, it has the newer firmware on there, so even though it was at 0%, it was still able to get enough of a charge to go ahead and turn on and get working. I'm wondering if I take this battery and move it over into that pack, or take maybe the control board off of that one rather and move it over onto this battery, if that will then allow this to charge up. Because I'm seeing 3.6 volts on every cell here, and based on the nominal voltage readings and what we should get out of a 14S battery, this appears to still be a good unit. I'm not seeing anything out on here, at least at this point, that tells me that this is not going to end up being a good unit. So I'm going to leave it here for now, guys. Next time we get together, we're going to be taking this pack, moving it over to the other unit to see if it will charge. Absolute push come to shove, we still have that AC charging circuit off of this pack that we can move over to the other unit and get at least one working out of here. Oh no, why did you put it back together? I didn't. So this is the second Delta unit. I've gone ahead and torn down the AC components from it, just because we already saw that a few moments ago and didn't really want to bore you guys with it again. So yeah, I've got, oh, actually, that's interesting. Where did that come from? One moment, please. I just noticed something. So what I was noticing here, guys, this is the first time I've had this under the correct light. I was working on it over on the larger workbench, just because I had a little bit more space. And I noticed that there was some, what looks to be little flakes of copper. They do move, and I can pick them up and get them on my finger there. And then when I look over just a little bit, and I'll move this over for you guys. There we go. And if I move these out of the way, I think something got burnt here. Now, it's not the right, well, I guess that could potentially be from a cell inside of there, but I wouldn't expect to see copper like this, and I wouldn't have expected this unit to charge. So I planned on opening this up by saying, hey, it works. Because this unit did actually charge up to 100% with the DC charger. Got no errors, no faults, everything was working perfectly, except for, of course, the AC circuit. Now, seeing this damage here is making me wonder, did a cell pop, or is there something on the AC circuit that popped? So I've pulled it back out and pulled it back over here, and I want to take a look here. So this guy would have gone upside down like this, meaning the components here on this side would be right around where that went a little haywire. Now, I don't see anything immediately that looks as if it has popped. Wait a second. No, the other board goes on that way. I was looking at the wrong side of the board. That one goes right side up because you have to have all the connectors on it. Where did it go? Where did I put it? There it is. I was looking on the wrong side of the board. Ouch, that hurts. All right. So we don't have a bad cell. We have a exploded circuit board. Somebody actually did overload this thing, and this is phenomenal news, guys. I might be able to fix this. So I don't have an easy way to set this down. Let me put it on top of something slightly insulated. There's nothing conductive on the top side there, but nonetheless. All right, so if we take a look down right there, there's our culprit. So it looks like, so there's a connector that goes from this pin right here. I'm not sure what it is, so I'm not going to touch it. Probably comes off of a relay of some sorts. And it connects to this group, I'm assuming, of pins right in there. That is completely blasted off. So it looks like what happened is it did in fact get a surge or a jolt. Something caused this to fry itself, essentially. The good news on that is that I'm seeing good trace left here. So this is all that waterproofing stuff, and that's what we saw dripping down onto the other board. And this is, yep, there's their copper trace. So that's what actually tore off and went kablooey. And what I can possibly do is actually run a wire. I need to get something, I'd probably go with like a 18 gauge on that, and go straight from that pin over to this pad here. And I may be able to fix this board. Oh, that is such good news. Because then we've got a working unit perfectly. I want to try and put the other AC unit in first, and I actually want to move this over to the non-working unit, the one the battery is not currently turning itself on for whatever reason. But it's good that we were able to find this. This tells me for sure that the battery pack that's inside of here is not damaged. We had very little copper on this board, probably less than a couple of grams of copper. So it shouldn't have gotten down into the other battery and caused any kind of trouble there. So awesome, awesome news there. I'll bring it up real quick just so you guys can have another look at that carnage. So this is what happens when you overload a circuit, when you go ahead and try and push too much power through something. If I look on the other side, and guys, I'm not an electrical engineer. I don't know 1000% what all of these components are, but it does look like we have some kind of, that's 4 pins, so it's not a MOSFET. Maybe it's some kind of a rectifier that goes into this transformer, I think. Somebody correct me in the comments, please. I'm sorry. I probably should look it up so that I'm better educating you guys, but I'm not an electrical engineer. I don't ever intend to work much on the AC side of things here. I can tell when a trace is blown, and that I can probably fix. So we're definitely going to be trying that out. But when it comes to knowing what each of these components is and what it does, that's not the depth that I've ever gotten into the electrical engineering side of this venture. So we're going to go ahead and put this AC board, the one that we know does work, inside of this unit. What I want to do from that point is go ahead and get the MPPT charger back on it. I believe that might be where the brains is of this unit. So I'm going to actually try and move the MPPT unit from the dead battery unit in here and see if I can do a firmware update on it. If so, maybe we can get the BMS to turn back on that one, or at least stay on long enough to get a charge into it. For now, let's go ahead and move some of my wires out of the way here so that I can set this board in here without having to worry about crushing anything. Wow, this is really cool, guys. I am looking forward to this. Now, there is hope for the other battery as well, because I did find that the BMS has a reset procedure on it. The battery pack still having 40 volts in it really makes me feel like it is probably going to be fine. But what do I know? I'm just a guy in my garage. All right, A, B, hey, that's really nifty. So I've got a B stamped in here, an A stamped in here, and I got an A and a B on the board. I can't screw this up. They really make this dummy proof. They knew I was going to be in here. There we go. All right, so now we've got our ground in. Less likely that I'll get shocked, maybe. All right, so the last plugs that we have here are all going to go to the MPPT module, which also plugs into the screen here. I'll do that first. All right, gonna get a couple screws in on this guy, and yes, I can still get to all those other screws I needed, which is beautiful. All right, we only have one more connector here as far as I know to get plugged in, and that's gonna be this main XT60 from the battery into the MPPT board. And then we should be ready to see if she works. All right, so in theory, everything is now currently on, or able to be on rather. All right, on this side, I now show my 100% battery. Maybe, there we go. Are you staying on? We're gonna stay on? We're gonna do this? I don't show a Wi-Fi emblem anymore. Oh, nope, there it goes. It did connect. So yeah, that tells me that the smarts are going to be in this front panel. I'm going to want to take this off and swap it with the other one to do that software update. Let's see if our AC works though. So previously when I would push this, it would click on and then it would just immediately click off. No more AC overload. Beautiful. So this is now, as far as I can tell, a fully working unit. Everything here is good. All the different inputs work. It is connected. It's got 100% battery currently. This guy's fixed. All right, so we are back up and running. We've got our Max charged up to the max and working, turning on first time every time. I think that I'm a little torn. I don't have my solar set up at the house yet. And so I think that this is probably just going to end up being a garage backup now. And I am a little curious as to whether or not this will power my air conditioning unit, because by default, the Rivers won't. The Rivers don't have any chance of actually powering up my AC unit. They will only, they'll turn the fan on, but then they trip as soon as the compressor tries to turn on because of that instant surge of a lot of electricity. So this one should, because it does put out up to 3,000 watts. So this one should be able to do that. And even the 1,600 that it puts out by standard should be enough to handle that initial surge. All right, guys, so not really a super exciting end to this video. We got one of the units working, so good news there at least, but the second unit is still sitting right in front of me. I don't get it. I don't know. So that's where we're gonna have to leave it for this one. Next week, I plan to be back to the Rivers unless anything else pops up midweek that I just really want to work on. There's a couple of other things that are going to be, or that have popped up on the channel recently. As I became eligible for monetization, there were some things that I turned on, some things that I haven't. I'm not going to turn on mid-roll ads. I don't personally like ads, and I understand that's where the money comes from in YouTube, so maybe I'm shooting myself in the foot with this, but I'm not turning those on. You may get an ad at the beginning of my video. You're going to get it regardless if I have it turned on or not. There's either I get paid or YouTube just keeps all the money. That's the thing. There are some potential channel sponsorships that are going to be coming up soon. If you haven't already seen my post about it, guys, I have posted on my website a full partner requirements. And that goes out to anyone that reaches out to me and says, hey, we want you to go ahead and hawk our product. So I had a couple of companies that reached out. One of them wanted full creative control over the video. They wanted final say on anything that I said. And they also wanted me to go in and delete comments if anybody else talked badly about their product. It was one of these power supply companies. I'm not going to name names because I don't want to be known as the guy that goes out and shames sponsors, because that obviously will reduce the amount of business that I potentially have coming in. Ultimately, I told them, no, I'm not down for that. I'm going to tell my viewers like it is, and they should expect to be able to trust anything that I do review. I got reached out to by another company that had some weird rules. It wasn't anything, they weren't going to tell me how to write the video or anything, but they wanted full copyright control over the video afterwards. And it was for the equivalent of about $15, and that didn't sit right with me. Not that I think I'm some highfalutin YouTuber, but I'm not putting multiple hours per week into $15. I get paid more than that in my day job, and I need to be able to focus on that too. This kind of stuff I do because it's fun. I did have one other company that reached out, and I'm working hopefully to get something rolling with them right now to hopefully help provide some additional equipment that I dearly need to be able to continue on these journeys properly. As some of you have seen, my things like my power supply, not necessarily the greatest. The meter that I'm using is a DC only meter, which doesn't help us when it comes to some of these AC appliances that we may be working with. So something in the works. Hopefully I'll have more to share on that here soon. Other than that, like, subscribe, go ahead and make sure that you keep an eye out on the post. I'm working on one other thing that I don't want to share yet, because honestly, I think it might be falling through, which kind of stinks because I recorded a whole video for it. I'm gonna have to organize all of these thoughts afterwards in the edit. That's gonna be the fun part. Thank you again so much for watching. Go ahead and hit that like, hit the subscribe if you feel like it, and I'll see you back here next Monday.